All right, so in this video, I want to show you guys a little bit more about how to do averages, ratios, and percentages and things like that. So averages is simpler. Let's say, for example, you planted 3 beans and on each condition, and you had one condition that was like I put baking soda on it, and then the other one was just water that didn't have the baking soda. Okay, and let's say on this one, the final heights of the plants were 10 centimeters, 9 centimeters, and 3 centimeters. And then the ones that were just, the other way around. This was 0, 0, and like 2. And this was 13, 12, and 9, right? So what you would do to do averages over here, first of all, let's do range, actually. Range is easy. Range, you get the maximum value minus the smaller value. So that would be 2 minus 0 for the left side, which is 2. And then over here, it would be 13 minus 9, which would be 4. So there's less variety in the data here than here, right? So with water, plants grew more, and so they were able to show their natural tendencies to grow compared to baking soda where they barely grew, so there's not a lot of variety there. So see me spouting a pattern there, even by just looking at the range. But another way you can look at that is look at the averages, and that will probably give us another pattern. Now, with averages, you basically do is you add all the numbers and divide it by the number of numbers you have. So I had 3 data points because I had 3 beans. And then divided by that. So this would be 2 divided by 3, which is about 0.66 centimeters. And if I do it on the other side, it would be 13 plus 12 plus 9. And that's going to be 25 plus 9, which is 36 divided by 3. And 36 divided by 3 is 12. So you get 12 centimeters as your average. And so very clearly, we see another pattern over here. We see that if you just give water, it grew a lot more than with baking soda, which was obvious from the data itself as well. But this way, at least you have average to compare, right? Another one you can do is talk about a ratio. You can do a ratio of the number of beans that grew versus not grew. So in this case, you have 2 that, one that grew out of 3 total. So your ratio is going to be 1/3 of these things, or 0.33 or 0.3 repeating will be your ratio. Okay, which could also be converted to a percentage. If you multiply this by 100, you can say 33% of the baking soda seeds grew versus the water, all 3 of them grew. So it's 3 out of 3, or 100% of the beans grew. So in this example, I showed you how to do ratios. I showed you how to do averages. I showed you how to do range. Mode would be the most common data point. So in this case, there is a mode. It's 0. But here, they're all just as equal as each other. There's not a number that repeats, and so there is no mode for the water data. Medium would be the middle data point if you put them in numerical order. So if I write this in numerical order, the middle point would be 0 for this group. And for this group, it would be, it's kind of in reverse order here. So the 12 would be the medium, which also happens to be the average. So that's interesting. Sometimes the medium and the average do agree, right? So you can do mode, you can do averages, you can do ranges, you can do ratios, you can do percentages. The more math that you do, the better your analysis is going to be, and the more patterns you will have to make an analysis. In this case, I could say the water has more variety of numbers than the baking soda does, since the range is bigger. I could also say the water has a clearer, better growth due to the averages and to the fact that the ratio is better. And so more math, more ability to spot patterns. That's how you do it.